Okay, the next section is 4.1. So we're talking about trigonometry now in this chapter. Start with angles and their measures. So we'll talk about angle measure, both in degrees and radians, arc length, and a little bit of angular and linear motion. Okay, so we'll do degrees quite a bit, which obviously we know there's 360 degrees in a circle. There's different units though to use to measure angles, so we'll also use radians. Now what a radian is a radian is the angle at which the radius and the arc length is the same from a sector of a circle. So it actually comes from the arc length formula, S equals r theta, which we'll use, where this is in radians. So if the arc length is 5 miles and the radius is 5 miles, then that angle would be 1 radian. Divide both sides by 5, and you get 1. So it kind of follows from the arc length formula that basically if you have an arc length that's the same length as the radius, then that angle is always 1 radian. Navigation always uses due north as 0 degrees, and then you move clockwise from there. So keep that in mind if we're ever doing a navigation problem, kind of change. In this class, we start with our 0 degree angle here. But with navigation, you know, in aviation and shipping, navigation would be straight from due north and then clockwise from there. Okay, so here's an example then. We want to be able to convert degrees to radians. To convert degrees to radians, we have like 105 degrees, 135 degrees times pi over 180. This is the unit converter. It's pi radians over 180 degrees. So we know that pi equals 180, so we're really just multiplying by 1. But what we do is we cancel these units and change the units. So this ends up being 45 goes into this 3, 45 goes in 184 times, so it ends up being 3 pi over 4. Okay, we also want to be able to convert from radians into degrees, so it's just the opposite. So this is radians, so we'll multiply by 180 degrees over pi radians. That way the radians cancel. We don't usually write radians as well, so that's not always going to be written out. Keep in mind that if you see pi, if you don't see the degree, you can assume it's in radians. The pi would cancel here. 6 goes into 180 30 times, and so this would give you 210 degrees. All right, now arc length. I just give you the formula. I'll give it to you real quick again right here. The arc length formula is S equals r theta, which is right here. Now, the key thing in this formula is that this theta is in radians. So keep in mind. You can use a different formula if you want for degrees, but I just usually make sure that I convert to radians first, which is basically pi over 180, and then that's where you get this formula. So I always use this one to make sure you're in radians. So the next problem then, we want to find the length of an arc. So we're using S equals r theta. The angle is 1/4 of a radian, so that goes in for theta. And the radius is 3 inches, so that gives us an arc length of 3/4 of an inch. Here's another example problem. If we want to find the perimeter of a slice of pizza, that's 30 degrees, and we've got an 8-inch radius. What we're looking for is, we want to find this arc length for sure, and we want to add 16 to that, because we've got 2 radii to add on. So let's find the arc length. We'll use S equals r theta for that. We want to make sure we can take that 30 degrees and convert it to radians though, so we'll multiply by pi over 180. 30 goes into this 6 times, so it's really pi over 6. So we have pi over 6 times the radius of 8. This simplifies because 2 goes into this 4 times, it goes into this 3 times, so it's really 4 pi over 3. Now we need to add to that though, because that's just this length, 4 pi over 3. We need to make sure we add 8 and 8 to get the whole perimeter of that slice of pizza. That's the exact form, and obviously you can do that as a decimal as well. But we'll do problems similar to that in the homework. Okay, a couple random things that we'll put in the homework. I'll put some problems about angular and linear motion. So angular speed is measured in revolutions per minute, and linear is measured in units like miles per hour. Obviously we can change these units as we see fit, but that's the basic concept. You're also going to want to know what a nautical mile is. It's the length of 1 minute of arc along the Earth's equator. So the question is now, what is a minute? Well, a minute is a degree of measurement. 1 minute, we denote it like this. That is equivalent to 60 seconds. And what is a second? Well, 1 degree is equivalent to 60 minutes. So basically we can break down 1 degree into 60 smaller parts. We'll call those minutes. Sorry, that's 1 slash. 1 degree is equal to 60 minutes, and 1 minute is equivalent to 60 seconds. So basically we can break this degree into really small parts. And we need to do that because, for example, if we talk about latitude and longitude on the Earth, we need smaller degrees. A nautical mile is 1 minute, but you can imagine that if you want to talk about if you want to get a smaller location, a smaller arc length on the surface of the Earth, you need to use a smaller measurement. And instead of using 0.00001 degrees, it makes more sense to break it down into like we do with feet and inches, and smaller units of measure. So that's what we have. 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. That's the basis of degree, minutes, seconds. That's on your calculator as well. So this is how GPS works and navigation works, where they're all based on centers, based on angles from the center of the Earth. So latitude is based on angles from the center of the Earth to the equator, like this. And longitude is based on the center of the Earth angles from the prime meridian. It's a little hard to draw that, but you get the idea, based on that direction of angles. So we can do an example then. Let's say that we're 67.589, I'm just making this up, degrees for latitude. We can put that in degrees, minutes, and seconds. And there's a couple different ways to do that. To do it by hand first, we would do 0.589, and we would that's degrees, so we want to convert that using these converters right here. So 0.589 degrees, we're going to multiply that by 60 minutes, are in 1 degree. That way the degrees cancel, and that gives me 35.34 minutes. So this thing becomes then 67 degrees, 35 minutes, and we're going to now take this decimal right here, 0.34, we're going to convert that to seconds. So now let's just isolate that 0.34 minutes, and let's multiply that by 60 seconds is equivalent to 1 minute. So the minutes will cancel, and we'll get that in seconds. So 0.34 times 60 gives us 20.4. So this would be equal to 20.4 seconds. So we'll just add 20 seconds on there. I know it's technically 0.4, but I'm going to round down for our purposes. So if I have an angle of 67.58 degrees, that's equivalent to 67 degrees, 35 minutes, and 20 seconds. And that's what we'll use to describe then this location right there if this angle is 67.589 degrees. So that's basically the foundation of GPS and latitude and longitude. Now we can do this on our calculator. If you type this into your calculator, it does it pretty quickly. If you have 67.589 and you go to second angle, convert that to degrees, minutes, and seconds would be 4, and it'll do it for you. 67 degrees, 35 minutes, and 20.4 seconds. I left off the 0.4, but you could also go back and forth. If you just enter this into your calculator and hit enter, it will go back. So if you enter something in degrees, minutes, seconds, and hit enter, it'll give you the regular degree. And those symbols, by the way, are here. So if you type it in 67 second angle degrees, and then 35 minutes would be second angle minute, which is 2. And then you also have 20.4, so that'd be 20.4 seconds. Now seconds is the tricky one. It's right here by the plus sign. You have to hit alpha plus, and then that will give you your answer of 67.589. So that's how to go back and forth on your calculator from degrees, minutes, and seconds, and from degrees, minutes, and seconds back into degrees. All right, that should be it, and hopefully the homework will help us iron out these things, and we'll learn them better. Hope this helps.